P, R, and S lie on a circle with center O, as shown in the diagram below. So this is P, this is R, and this is S, while Q lies outside the circle. So this is Q here. This is your P, this is your R, and this is your S. So we are told to find angle PSO. Angle PSO. So this is P, S, and this is O. So we are told to find this angle here. Angle PSO. Now you know that this is a circuit geometry problem, but normally when you're trying to find missing information in a circuit geometry, it's like you're trying to solve a puzzle. When I mean solving a puzzle, I don't really mean playing any kind of game, but I really mean it's solving a particular kind of puzzle that will help you in determining the missing information of the problem statement. Now looking at this, what I mean by finding or solving a puzzle, you could just simply begin to fill out information based on the ones that you can quickly find. For example, when you look at this whole circuit geometry, you would observe that we've been told to find this angle here, but then we don't really have sufficient information to find this angle here. Now what I'm going to do is I'm going to begin to use the information I'm given and begin to fill all the information I can fill based on the information that I'm given. Now what you'd observe here is, considering this triangle, I've been given 20 degrees and 35 degrees. Now I can use, because when you have 20 and you have 35 degrees, I can use that to find the missing information that we have here. That is this angle here. And then how do I do that? Since I know that the sum of the angles in a triangle is 180 degrees, so to find this missing angle, so I just know that 20 plus 35 plus the angle R must give me 180 degrees. In other words, 20 plus 35, that is 55, plus R will give me 180 degrees. So my R is just simply 180 degrees minus 55 degrees. And 180 minus 55 degrees is just simply going to give you 125 degrees. So that tells me that the angle I have here is going to be 125 degrees. So now I've used the first two informations to fill this missing part. But my aim is, I'm still coming here. I want to find this information here. Now see the way I begin to grow or follow the bridge. Now the next thing is, since I've gotten 125 degrees based on these two information, then I begin to think, what other missing information can I find based on this new information that I've gotten? Now and again, you would observe that what you have here is a straight line. Now if from here to here is 125 degrees, and I know that the sum of angles on a straight line is 180 degrees, so that simply tells me that I can use this new information to find this missing angle here. Because I know the sum of angles in a triangle is 180 degrees, so to find this missing information, if I call this x, so how can I find x? Well, to find x, I know that 125 plus x must give me 180 degrees, because the sum of angles on a straight line is 180 degrees. So therefore, x, when you subtract 125 from both sides, you have 180 negative 125 degrees. So 180 minus 125 is just going to give you 55 degrees. So that tells me that this angle that I have here must be equal to 55 degrees. So x equals 55 degrees. Now I'm done with that, but my aim is still to come here. I want to find this missing angle. You can see I begin to solve the whole thing like a puzzle. I've gotten 125 degrees, I've gotten 55 degrees, but my aim is, how then do I find this missing information? So I need to get to this triangle POS. If I can get to this triangle POS, then I guess the problem is going to look more simpler. Now before I move on to the next step, I want to show you something, or explain some things to you. Now you recall, the angle at center of a circle is twice the angle on the circle subtended by the same arc. Well, let's show a diagram to illustrate this little theorem that we have here. Now what I mean here is, it says the angle at the center of a circle. Now this is the circle that we have here. Now the angle at the center of this circle is this angle that you have here, the angle that you can see that is shaded here. This is the angle at the center of the circle. So what the theorem says is that the angle at the center of the circle is twice the angle on the circle subtended by the same arc. Now the arc that we are taking into consideration is arc AB. So arc AB subtends two angles. The first angle it subtends is the one at the center of the circle, which is angle O that I've shaded, and the other angle it subtends is the one on the circumference of the circle, which is this small angle here. Now what this theorem says is that if the angle here is x, then the angle here is going to be 2 times x. That is, the angle at the center is twice the one subtended by the same arc at the circumference of the circle. I'm going to use this information in the next step I'm going to take over there. So let's move on to the next thing there. So based on the information that we have or that we've just obtained below, it says that now if you consider the angle that we have here, that is this angle that we have. Now looking at this triangle here, triangle PRS. Now considering triangle PRS, you'd observe that it is subtended by this arc here. So if you consider arc PS subtends two angles. So the first angle arc PS subtends is this angle here at the center of the circle, and the other angle that this arc PS subtends is also this angle here at the circumference of the circle, as you can see. And based on the theorem I just showed you, it says that whatever angle you have at this point here, what you're going to have here is going to be 2 times what you have there. So this is just going to be 2 times 55 is going to be 110 degrees. Okay, now this whole place is becoming messy. Let me bring this out. So what I have, so I'm going to draw angle POS. So what I have there is I have P. So let me draw this. So we have something like this. Yes. So we know that this is P, this is O, and this is S. So that is what we know. And then based on information we just derived now, we've obtained this angle here to be 110 degrees. And our aim is we want to find this angle here. Now how do I find that angle? Now what you'd observe is that this is the center of the circle. So from the center of the circle, the length from this point to this point is always going to be your radius, right? And here is also going to be your radius, because any line from here to the circumference of the circle is going to be the radius. So that means here is R, and here is also going to be R. Now what this implies is that this is an isosceles triangle, and what I mean is that the length of OP must equal the length OS. Now if this angle here, if the length from here to here equals the length from here to here, what that implies is that the angle here must equal the angle you have here. So in other words, if here is theta, then here must be theta. So, and again, we also know that the sum of angles in a triangle is 180 degrees. So that quickly tells me that when I add 110 degrees plus theta, then I must obtain 180 degrees, because I know that the sum of angles in a triangle is equal to 180 degrees. So in other words, 110 degrees plus theta is going to give me 2 theta, and this is equal to 180 degrees. So since we want to find theta, so we're going to deduct 110 from both sides. So this goes off. So you have 2 theta to be equal to 180 negative 110, you're going to have 70 degrees. So to find this, I will divide both sides by 2. So we have this goes off, and then your 2 here is going to be 35 degrees. So in other words, my theta equals 35 degrees. So again, our aim is we want to find this angle here, and we call this angle, we call it to be theta. That is, this angle here is theta, and we've just shown below that the angle theta is 35 degrees. So let's check our option. So this is the solution here, 35 degrees.